Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. My name is Clem Silverman, and this week we are visiting one of the companies on our Technology Developer Accelerator Programme for SMEs, or TDAP. Oxford RF develops sensors for automated and autonomous vehicles which can see the world in front, behind, and all around themselves in incredible detail. Oxford RF is a startup that has developed a 360-degree solid-state radar system. In January 2023, the company completed its journey through APC's TDAP program, which provided grant funding and business mentoring to support this kind of innovation. It has also received backing from Zenzic's Connected Autonomous Mobility Scale-Up program. As a result of this, and collaboration with WMG, Oxford RF are now exploring commercial opportunities and bringing its application to the market. Here's transport and energy journalist David James to explain more.
One of the issues slowing down the development of autonomous vehicles is the number of different sensors needed to provide 360-degree situational awareness, even in difficult conditions. More sensors means more cost, more power consumption, and more data to process, which can cause critical delays in decision-making. Oxford RF, with the support of the Advanced Propulsion Centre, has developed the world's first 360-degree solid-state radar, which is designed to help overcome many of these issues. We went along to the Warwick Manufacturing Group, who are helping to test this new radar, to meet Dr Kashif Siddiq, the CEO and founder of Oxford RF, to find out more. Just talk about Oxford RF as a company.
We are sensors experts, and we looked at the driverless cars market and the way driverless cars are being developed these days, and we thought there is a burning problem here. There are too many eyes on the vehicle, because if you think about a driverless car and a normal car, the difference is that the driverless car has extra eyes and a brain, which a normal car does not have. And we thought that we can do something better, and we can design a proper sensor for autonomous vehicles. And the way we designed the proper sensor is that we sat down and thought about the different problems, and the biggest problem turned out to be the cost of the sensors themselves and the sheer number of sensors around the vehicle. And we thought, what can we do about this? And that led to our innovation, which is to combine the old technologies and literally evolve the sensor technology to the next level, and combine the solid state sensor idea with the old conventional 360-degree spinning idea to come up with a solid state 360 radar sensor.
So for the layperson like myself, just explain how autonomous vehicles work, because as a layperson, we're very used to just the magic of technology working, but it's quite complicated. Just explain how autonomous vehicles do self-drive.
Absolutely. Like you said, it is quite complicated. However, we can break it down into a simple explanation, which is that if you take a normal car and if you want to convert it into driverless, then we need two things. One is the eyes and the other is the brain. So a car will see the environment through the eyes, which is the different types of sensors, your cameras, LiDARs, and radars. And then it needs a brain, which is the central processing, which is the artificial intelligence and machine learning type algorithms. So those are the two key components, but there's a whole host of components that needs to come around them to make what is called a full stack self-driving vehicle.
Just explain a little bit about what those sensors are at the moment and what each of them do and the benefits and disadvantages of each.
If you think about a human driving the car, we use vision sensors, which is our eyes, and hence why there is a big drive towards using cameras to actually sense the environment, and it makes good sense. The only problem is that cameras will not work very well when there are adverse weather conditions or adverse visibility conditions, which are separate, because in adverse weather you have rain, snow, fog, those sorts of things. But in adverse visibility, it could be a sensor that has accumulated dust on it, or it could be smoke in a tunnel, for example, those sorts of safety critical situations. So cameras need to be augmented by other sensors, and one of the primary sensors is radars. Radars have the benefit that they can work regardless of the weather conditions, regardless of the visibility conditions. You don't need to clean them. And even if there's a tunnel filled up of smoke, radars will produce a perfect picture of the environment. So it's a safety critical sensor. The third sensor in the stack is called LiDARs, and it is based on infrared principle again. And also it can produce a high resolution image of the scene. So the three sensors in a full stack driving situation, they complement each other, they produce data and augment each other to produce a scene that can be used for autonomous driving.
Now, as a layperson, the only understanding we have of radars is watching the films where you see the ships and there's the radar screen going around and you just get a little blip. What's the kind of resolution we can get with a radar these days?
We can get sub-degree resolution, which means that if you think about the whole space, it has 360 degrees in it. And 1 degree is 1 by 360th or about 1 by 400 of the full environment. And with radars, we can get sub-degree resolution. So it's pretty high resolution these days.
And could that be turned into an image so a human could look at it and it would look like a picture of the world?
Absolutely. And that's one of the latest innovations in radar is actually called imaging radar. So definitely the radars can build up a scene around them as the vehicle moves. In fact, the technology has been pushed even further. We are talking about 5D radars now. And the fifth dimension is exactly using the motion of the vehicle to improve the imaging resolution. So absolutely, radars can definitely be used and are being used for imaging.
Okay, so there are radars on vehicles, there's LiDARs on vehicles, there's cameras on vehicles. You've alluded to the problem of having so many sensors. Just go into that a little bit more detail. Why is it an issue having lots of sensors, both from the processing point of view and the costs and the latency? What are those issues that you need to be aware of if you're designing an autonomous vehicle?
Cost is the biggest driver in any commercial system. If we want to bring autonomous vehicles to the market, it has to be at a sensible price point. Now, there are too many sensors on a vehicle right now purely because the sensors need to augment each other. There are cameras, there are radars, there are LiDARs, and then you have to put those sensors all around the vehicle, which is a problem in itself because installing them is very costly in the vehicle. The sensors themselves are very costly, and then they generate an enormous amount of data. That data needs to be processed, and there could be latencies, as in delays in decision making. So let's say a sensor has detected a person, like a child. If it has to process too much information, then there could be a delay in reaching a conclusion that it is actually a child and applying the brakes. Now, that's a bit of a problem. So definitely driverless cars, they should have as less a number of sensors as possible. And a part of the reason why those sensors are too expensive is that there are spinning parts in some of the 360-degree sensors, and that increases the cost 10 times over a solid-state sensor.
So this seems like a good point to talk about your innovation in a bit more detail. So it's a 360 solid state radar. Explain a little bit more and some of the technical challenges you might have had to overcome to produce this.
So solid state means that there are no moving parts in a component. And a solid state 360 radar is a radar sensor that can sense the full 360 degrees or build a map or an image of the full 360 degrees without having any moving parts in it. And this is the world's first sensor, and this has been the key innovation, going from the traditional thinking, because this is like breaking like a really huge barrier. Like people are used to thinking about 360 sensors need to have a moving or a spinning component in it. And solid-state sensors, they only have a limited field of view. It's not limited to radars. It's also limited to other solid-state cameras, solid-state LiDARs. However, we have broken a really high barrier, which is that we have fused the two technologies, doing the full 360 degrees. And we have had to invent our own new antennas that could help us to put these sensors in a low-cost way, reduce the cost of the sensor, and also look in the full 360 degrees without moving any parts.
Can you explain in a way that I might understand about how a solid state radar works?
Absolutely. So a solid state radar is effectively like a bee's compound eye. Just like a bee will have a compound eye, like many eyes within an eye. So exactly like that, a solid state radar or a solid state sensor will have many sensors on it. It's called an array of sensors or a grid of sensors, which do not move themselves. However, they can sense the environment. And just like we have two eyes, so we can see the scene from two different aspects. And that's why we can position and locate things more accurately. If we had 10 eyes, then we would have super resolution. And that's exactly what bees do. They have a compound eye, so they have many eyes in one eye. And that's why they can locate objects with a really high precision, even though the eye itself is really small. And that's the principle that we are using in it.
And does radar work by emitting some sort of energy and receiving the reflection? Is that right?
That's right. It's an active sensor, which means that it transmits a signal out and then receives a signal back if there is an object in the space. Generally, this is called echolocation.
Does it make an issue then if you've got a 360 sensor to have a car in the way, because the car's going to be in the way of some of that field of view?
Absolutely. And that's why we are reducing the number of sensors, but to cover the full 360 degrees, we will use 4 sensors installed on a car. So this will be on the 4 corners. However, we have been clever in the way in which we are using them, because the 4 sensors, they augment each other. So previously, if a sensor failed, then because of its limited field of view, there is no other sensor to back up for it, which makes it impossible to use it in a safety critical application. However, we have because we can use 360 degrees, we can limit the vision to 270 degrees even, and then we can install 4 sensors on the 4 corners of a vehicle, and then they get an overlapping coverage.
So cost is critical in your estimation of moving the technology forward. What kind of design constraints, parameters did you put on yourselves to design something that would do the job that is cheap enough to manufacture? What have you learned from that process?
So we come from a long background of designing sensors, and part of the cost comes from having those mechanical components inside a sensor that will spin, and then part of the cost is putting them together. So it's a complicated process to make sure that every sensor is well balanced and it has the right optics in it, the right electronics in it, and test them in an environment so that we can mass produce them. So one of the big goals that we had was that it needs to be a solid state sensor. And then we looked at how do we reduce the number of sensors. Then it's definitely has to be a 360-degree sensor that can replace multiple with one. And that gave birth to the idea of a solid state 360 radar. Then the question was, how do we actually do it? And that was the next step, the part of our innovation.
This is probably a good time to talk about the Advanced Propulsion Centre have provided funding for the development of this sensor. Just talk about what that funding's been used for.
Any hardware startup like us needs a defined amount of funding and support to get us off the ground. And hardware startups, they need more funding than software startups purely because we need to create hard products. And as they say, hardware is hard. The APC is running the TDAP program, which is one of the best hardware accelerators in the UK. And they are giving us the necessary pre-seed cash support and also the mentorship. And they also make connections for us, which are really critical, access to the market. So there's a lot of resources that the APC is bringing on the board, including the cash support. And I think that's very critical for the UK ecosystem, I would say.
So in terms of that funding, has it been used to actually physically create the hardware, or is it testing, or is it the entire process?
It's a bit on the entire process. So we started off with TRL2 when we started the program. And the program comes in 2 phases. First is the market validation phase. So we use the market validation phase to create our business models. And so business models means how do we actually sell the product. And then also we increase the technology readiness level, or TRL, from 2 to 3, which meant that we had a proof of concept in our hand. Maybe it's becoming a bit more technical, but we had a proof of concept in our hands, which we actually mounted on our company car and we tested it. In the second phase of the TDAP program, that was purely the technology validation phase. And we have used that money to actually create prototypes, the ones that you will see today, and working on the AGV as well as the car. So a lot of the money has been used to actually design the product, and now it's being used further for testing.
So what difference has it made to Oxford RF to have access to APC funding?
We would not have been able to get off the ground in a simple sentence without the APC funding. It is an early stage funding program, unlike Innovate UK, which expects us to have reached a certain level of technology readiness before they would fund you. The APC fund earlier stage companies like us, and it is really a bridge that helps us to take a concept and create a product, validate our market, and sort of go on into the higher technology readiness levels where we can go into trials and work with other people like Zenzic and Innovate UK to take the technology to the market.
I know it's very early days, but what does that business case look like? What does the marketplace for this type of technology look like? How are you explaining it to investors and other people that are interested?
So the market is growing, and everybody realizes the applications of perception sensing. So for a solid state 360 radar sensor, the applications are almost unlimited. So they range from infrastructure radar, so we can install this radar on the side of a road and get traffic analytics data, to installing this sensor on actual moving platforms. For example, we can install this sensor on AGV platforms, which is automated guided vehicles, and we can install this on cars. And today, this can be used for ADAS, advanced driver assistance systems, which is things like your automatic braking when a pedestrian comes, or your automatic lane change assist. So today we are exploring commercialization opportunities with some large players in the market for these applications. And looking ahead, this is one of the ideal sensors to enable autonomous vehicles and speed up the process of bringing them to the market.
And I know it's very, very early days, but how are those initial engagements going with potential customers?
They are going really well. So first thing is that people understand straight away the innovation that we have brought to the market. And there is a strong customer pull in various markets, including the automotive sector and the marine sector, and some pull from the space sector as well, even to use these sensors on moving vehicles primarily.
And again, I know it's early days, but APC money is public money. It comes from the taxpayer. What do you think the British taxpayer gets back from investing in these kind of projects? Or specifically, what's the benefit for the UK in investing in your project?
So there's a multitude of benefits. First, this is the high-tech sector, and obviously there are studies on every pound you invest in this sector will give you a lot of money back in terms of the return on investment. But the way that works is that supporting creative technologies like ours accelerate the introduction of other larger technologies to the market, and places the UK on the forefront of the technological revolution that is happening today and will happen tomorrow. And this includes creating new industries, setting up new factories to produce this sensor. So that means it's new jobs created and new inward investment because it's new foreign exchange, because when we are selling our sensor outside of the UK, then that's foreign revenue coming into the UK. So there's a multitude of benefits there.
Is there anything we've not talked about that you think is important for people to know about the technology or the business or yourselves?
So the technology is meant to reduce the overall cost of introducing advanced driver functions and also driverless cars into the market. And our sensor is inherently resilient to jamming as well, because it's looking at the scene from multiple angles. So that is a big problem these days. If there are lots of cars, they have lots of sensors on them, then they start interfering with each other. But with our sensor, you can use them in an architecture so that the interference is minimized. Specifically, because we are using more than one sensor on the car, like I said, 4 corners of the vehicle. So we are looking at the scene from different angles. So this is like if there is a floodlight blinding somebody, then it blinds somebody in the line of sight. But if you're looking at an object from different angles, then the level of blinding will be less. And hence why our sensor is more resilient to interference.
Brilliant. Thank you very much for your time.
Thanks very much.
Thanks for taking the time to listen to this episode of The Road to Net Zero. You can subscribe on all the major podcast platforms. To find out more about our funding streams, visit the APC website, apcuk.co.uk.